Hello and welcome to a data mining experiment. So looking back on our OLAP, we were looking at a company that we were trying to start up. We needed investors and we needed money. Some questions that we asked ourselves were, what characteristics of a startup company can affect the amount of funding? And are there any relationships between companies' locations and the age of their funding? So with the data, before we went into our data mining, we experimented a little bit with partitioning the data into a few different data sets. And some of this was for analytical purposes, and other was for compatibility. And some of the softwares we used here were Weka and Orange Canvas. So this first data set we partitioned by age, and we divided it into three files. Kickstarter companies, or companies who haven't yet actually started but have received funding through Kickstarting, companies that were younger, and mature companies. With the mature companies, we went ahead and tried something out here. We wanted to see how the outliers node worked. So we had to select a few attributes, and we decided to go with the funding amount that we had categorized. And we ran ahead and ran a attribute statistic node. And this gave us a nice little histogram here that helps kind of see the distribution of outliers within our data set. And not too surprising, we see most of our outliers fall in the very high and highly funded amount. There were some in the low, which makes sense. And then for none, we actually categorized none at a lower value. It wasn't just zero. We figured that for most businesses, there was a certain threshold of money that you had to reach. So we threw that number in the low thousands just to make it a little different than just having zero. Next, we did an ARF data set for Weka. We went through and had to do a little bit of trimming, but we had 26,000 rows, and we kept the same 5 attributes: markets, country, US or Canada, state, age before funded aggregated, and funded amount categorized. So we went ahead and ran a few extra visualizations while we were at it, just wanted testing out Weka, and it's a very powerful tool for data mining, and it was very simple for us to use. So what we did here first was we went ahead and looked at the distribution of the created variable that we did for age before funded. And this is computed by taking the day the company started until the first day they received funding. Interesting enough, the average age of the company before they received funding was 3 to 4 years. So that gives us a short-term goal to reach in hopes of receiving some sort of funding that will help us expand our business. There is an exponentially negative trend going on here, and it makes a little sense because usually companies, as they're getting kick-started or actually funded in the beginning of their careers, it can generate a lot of hype and advertising, and that can initially lead to some funding in the earlier years, 1, 2, 3, or 4, compared to as companies get older. Usually if you haven't received funding, early on in your company's lifespan, then you probably weren't trying too hard for funding, or maybe it just, what you were doing wasn't necessarily in the eyes of the investors. So a little intuitive, but next we looked at the breakdown of startups by state, and New York, Texas, California, Massachusetts, it's pretty straightforward. A lot of big cities there. New York City, of course, all of California is very, very important to Silicon Valley. Boston, a very, very good place for startups and businesses as well. Here we went ahead and tried out Tableau to make a nice visualization to get an idea of the distribution yet again for startups and states. And like we said, California, Texas, New York, Massachusetts, we have California here, New York here, here's probably Boston. Here's Washington State, trying to catch up with California, probably not a bad state to go ahead and look at, as well as Chicago and Illinois here, Florida and Colorado. Just some interesting places to keep in mind when starting up our company. And here we went ahead, we had almost 700 distinct types of markets, And a lot of these were similar. For instance, there's software, digital media, e-commerce, curated web, analytics, a lot of technology-based ones, but within themselves they did have some different amounts of companies, so we went ahead and kept it in mind as to, maybe how specific we wanted it to be when we were picking a market to start up in. But luckily enough for us, out of two of the highest counted categories, software was definitely one of them, so a good indicator of us for a good chance of receiving funding. And here's another good visualization, yet again to do with markets, but it's within the startups from the past 2 years. So we have a good idea about what market we want to join. And can we create a data mining model with information provided to give us insight as to what companies receive more funding? So before we dive too deep in there, we're going to go ahead and categorize the funding received. Initially, the amount of funding was in dollar amount, but just for some purposes in the models, we're going to go ahead and categorize it into 4 different funding amounts. And like we described earlier, none is 0 and low are thousands. Low is above that, high and very high. Obviously, we'd love to look into getting into that high and very high category, but for the purposes of our analysis, we're going to try to capture everything, see maybe we know what the odds are of receiving low, or as we're shooting for, very high. So here's a look at, or a preview of our orange data model. And we'll go ahead and jump into here. Here's our data loaded into orange, as you can see, the type of market, country code, state code, nice color depiction of age before funded, and then our categorized funded amount. So before we look in here to our test learner results, we're going to take a look here at what the results are we're actually examining. We have the classification accuracy, which is proportion of correctly classified examples, sensitivity, the true positive rate, specificity, the proportion of detected negative examples among all negative examples, the area under the ROC curve, or the receiver operating curve, and the Breyer score, which measures the accuracy of the probability assessments, which measures the average deviation between the predicted probabilities of events and the actual events. And these were the 5 default scoring criteria, so we left them in. They're going to be pretty good as far as classification. We'll get a general accuracy, and we'll get to see our true positive rate and the negative examples. So here's our models. We went ahead and did it in a 70-30 training split. And we tried to predict low, and we tried to predict very high. And we ran it on 4 models, just throwing it out there, trying to get a feel for orange, and just if we left everything basic, how good of a model we could get. And for both models, we received pretty identical numbers, not too much difference within them. But the classification accuracies were rather low, under 40%, which for a business isn't necessarily promising, but still nevertheless a good starting point. The sensitivity was also pretty low. However, the naive Bayes model was able to manage around 50%. The specificity, all the same, around 0.8. Area under the curves, generally the same. And the Breyer score, the k-means clustering actually managed to get a 0.93, but not too much to go off of here. But as we said here, the classification accuracies were rather low. The naive Bayes had the highest true positive rate. The neural network had the highest specificity. The naive Bayes also had the highest area under the curve. And the nearest neighbor model had a Breyer score of 93, which was very high compared to the other models. Here are the confusion matrices that came off of the test learner, just giving a breakdown of the classifications and how they were able to match up in their predictions to the actual results. Here's the model with the highest sensitivity, and that was the naive Bayes, as I mentioned, and here's the lowest, the neural networks. So with almost 600 different market types and 26,000 instances, trying to run a classification model on this data was slightly difficult. The models took almost 20 minutes to build and compared the test learner. Also, we left all model settings to default, which probably needed to be adjusted for the data specifically. Further partitioning our data to the specific market that we're trying to look for might help our models, so let's do a quick data transformation and try again. So we're going to examine this select data node from Orange, and this allows us to apply certain operators to our attributes on different values. As you can see on the left here, we have the attributes, we have our operators, and we have our values. And here we did a few. We wanted to select the company market, and we wanted to see anything pertaining to software. And we also took age before funded, and we don't want to see anything immature. We want to see low, we want to see kickstarted, we want to see something that gives us insight as to our new startup. And then lastly, we took out funded amount equals to none because that's not necessarily our goal. So we wanted to see just with these attributes as to what we want in our data. And we went ahead and did this. And sure enough, it shrunk the data pretty good. We were down 91% to only 1,600 instances. So as this is what we want, we're going to have to see if it's going to be good or bad when we're building our models. So here's that in Orange itself. We have our 3 data sets that we managed to put together. We had a data check table just to make sure all went well. Here's the outliers that we had done earlier on the mature table. But we went down here to the select data criteria, and then we went ahead and made sure, went in and checked on our 1,600 instances just to make sure all was good, and sure enough, everything filtered out just to our needs. So, as we said earlier, we hope to narrow in on what types of companies receive funding in our ideal market. If all goes well, we can expand our model to hopefully do the same thing, but on a bigger scale. So here it is again. We went ahead, selected the companies. We went ahead and had to rename the variables because when we did this concatenation and merged the data sets, it assigns a cluster ID of 1, 2, and 3, and that was respectively for whichever ones you connected first. So mature was 1, young was 2, Kickstarter was 3. And we did that to avoid any confusion in the future, just in case something came up and said something was wrong with cluster ID, or maybe which one was 1, which one was 2, which one was 3. So now all that's left to do is run whatever models we want to test and see how our slimmed down training set, we can call, is working out. So let's go ahead and look at a classification tree. Let's see, was that large reduction in our data set too much? Did we eliminate any of the predicting power, after taking away 90% of the data? So here's the model itself, and our classification tree just ends up supporting our ideals that we discovered earlier. The tree takes the amount of funding received by a kickstarted company or a young software company and classifies them into their funded amount. This model is rather simple and intuitive and could use some more information. We can narrow down the location with state codes, or maybe instead of using funding category, we could just specify amount of money and try to do that and get a more defined classification tree. In conclusion, the analysis, we were able to get the idea of certain attributes that contributed to a company and the amount of funding they received. We tried reducing our data into a defined training set in hope of making good discoveries and new trends. However, if we had more information regarding companies that invested in startups, we could then narrow down our analysis even farther and look at trends within investors. If our data model could accurately classify investors and startups, we could work with both sides to successfully fund or invest into good businesses or markets. So about the software that we use. All of us had experience with Weka in academia, and we were able to easily create visualizations and understand basic summary statistics just through the GUI and the pre-process tab. This helped us to better understand our data and its distributions. We didn't run many models in Weka except to compare the first test learner results from Orange. We received almost identical classification accuracies on the models it built, so we didn't really include them. In Orange, we wanted to see what we could do with it. With minimal experience, we tried certain things such as concatenating, data selection criteria, renaming attributes, selecting outliers, and comparing multiple models with the test learner. Simple GUI and documentation put us on the right path to create robust models. However, some of the models created had rather low accuracies, within 30 to 40%. The classification accuracy may be okay, but to be confident in starting our company through receiving investment, we want it to be higher. These changes may come through fine-tuning the model criteria or through adding some breadth to our data. Lastly, we want to say thank you to Crunchbase for the data set. Here's a website we've included to Crunchbase so you can check out more information regarding them. And as we stated previously, the software we used was Weka, Tableau, and Orange.